This video is part of CAE Associates ANSYS e-learning series. CAE Associates is an engineering consulting firm in Middlebury, Connecticut, specializing in finite element analysis and computational fluid dynamics. We have been an ANSYS channel partner since 1985 and have developed our ANSYS e-learning series to help you maximize your software investment. Please visit our website, which includes an extensive resource library with over 250 items and counting in an easily searchable area. We also invite you to visit our Engineering Advantage blog, where we share insights from our many years of performing engineering analysis. CAE Associates also offers an extensive schedule of ANSYS courses taught at our Middlebury office. If you need help deciding on the best courses to take for your application, visit our CAE University page. The complete library of e-learning recordings is available for viewing in our resource library and also on our YouTube channel at youtube.com/CAEAI.
Okay, good morning, or good afternoon, I should say. Welcome to the latest in CAE Associates e-learning series. My name is Mike Yarn. I'm a project manager here at CAE Associates. Today we'll be talking about efficient solutions using the Remote Solve Manager. Now, if at any point you have any questions, please feel free to interrupt or submit a question through the chat window, and I'll do my best to answer them when we're done. So what's on the agenda for today? Well, what we'll talk about is what exactly is the Remote Solve Manager, something that comes with every Workbench installation, every ANSYS installation, but not everybody knows about it, and not everybody knows exactly how it can benefit them, so hopefully we can enlighten you on that front. After that, we'll talk about how we implement RSM into your workflow and how you use RSM to solve both single jobs, so a one-off analysis, and multiple design points. And finally, we'll talk about a new feature in version 14.5 called the HPC Parametric Pack, and we'll see what the benefits of using the Parametric Pack are. Okay, so what exactly is the Remote Solve Manager, or RSM for short? Well, RSM is a job queuing system that's designed specifically for use with the ANSYS suite of solvers. And there are two key benefits that we'll discuss. The first is that RSM enables jobs to be offloaded from your local machine and distributed to a remote machine for solution. So we can do our pre-processing and our post-processing on our local desktops, but we can run the solution, which is typically the most expensive part of doing an analysis. We can run that on another machine so it doesn't tie up our local desktop. And since RSM is an integrated solution, it's very streamlined. We don't have to write any batch scripts. We don't have to do anything special. Everything is easily configured within the Workbench framework. Now, another benefit of using RSM is it allows us to queue and manage multiple jobs. So if we have a number of users that would all like to use the same computer to solve or same set of computers to solve their analyses, we can use RSM to queue those jobs to make sure that they run as soon as there's computing resources available. To look at that another way, if we want to run multiple design points, say you're a single user and you've set up a number of different design points that you want to run, rather than having to submit those sequentially or write a batch script to run those in order, we can use RSM to manage the compute resources and make sure that as soon as there's a computer or resources available to solve the job, that RSM will go ahead and submit that and make sure it gets done in the most efficient manner possible. Now, another nice part about RSM is that its architecture allows a user to disconnect from a remotely running job. So if you're working on a laptop, you want to submit your job to a compute server and then go home for the night, you can shut down your computer, go home after you submit your job, and then the next morning come back in and download the results. So everything will be taken care of through the RSM layout, the project details, your solution files, everything will be managed by RSM. There's nothing in addition that you have to do. So what does a typical RSM workflow look like? Well, to understand that, we need to understand the different roles in the RSM hierarchy. And there's three main roles. The first, which you're certainly familiar with, is the RSM client. And that's your desktop. So that's where you're doing your pre- and post-processing, and that's the machine from which you want to offload a job. Now, when we offload that job, we're going to send it to the Solve Manager. And the Solve Manager that is the hub that receives jobs from the clients and manages the available resources. So the Solve Manager is going to have the queues. It's going to keep track of which compute servers are currently running jobs, and what resources are available. And when resources are available, it's going to submit those jobs to the compute servers. And the compute servers are the machines on which the jobs are actually run. Now, any machine that you have ANSYS installed on can play all three of these roles. So you can have your local desktop be the client, solve manager, and compute server, or any combination of those three. So it's a flexible environment. Just make sure you set it up so that it works to your benefit. So certainly I use this here at CAE in a number of ways. I use it one, to submit jobs to other machines we have in the office, or alternatively to submit jobs on my local desktop, but to have it run as a background process. So different ways you can do that, and different ways to configure RSM. Okay, so now that I've convinced you so convincingly that RSM is this great tool that you want to use, how do you go about configuring and setting up the Remote Solve Manager? Well, fortunately, it's a very simple process. At version 14.5, we have the Remote Solve Manager Setup Wizard. That's pretty easy to follow. All we need to do is open it up on the machine that we want to configure, select the appropriate role, and follow the prompts the rest of the way. So a very straightforward process. Now, in addition to that, I've put together an installation guide, which is out on our website, which you can download to kind of guide you through that process as well. It's called the ANSYS v14.5 RSM Installation Guide, and that's in the resource library on our website if you're interested in looking at that. Okay, so once we've gone through the installation procedure, let's take a look at what RSM actually looks like. Now, there's three main windows we have here. We have the outline tree on the left-hand side. We have the job window on the top right, and the details window on the bottom right. Now, in the outline tree, the Remote Solve Manager resources are listed starting with the Solve Manager. So in this scenario on my machine, I have my local desktop set up as the Solve Manager. So that's going to manage any available computing resources along with the queues that I'm going to submit jobs to. So if I open up the Solve Manager, you can see I have two different folders. I have the compute servers, which are any machines that I've configured that I want to use to run jobs. And if I right-click on one of the compute servers, I can look at additional properties such as the maximum number of jobs that can run on that machine. So for instance, if I have a 12-core machine, I can typically use that to run more than just one job at a time. Additionally, I can set the working directory location. So if I have a specific drive on that machine that's faster than the others, I can set it to make sure that RSM will run on that drive. So if I have a RAID array and that's the fastest drive, certainly I'm going to want to use that during runtime. So once the compute servers are configured, and that will again occur when you go through the setup wizard, what you need to configure within RSM is the queues that get submitted to, that jobs get submitted to. So I have listed here a queue named My Cluster, and that queue contains a remote machine and also my local desktop. Now, each queue doesn't have to include all of the machines that are available. It can just be a subset, but this queue is what's going to manage the computing resources, and it's what you're going to submit a job to from within Workbench, whether that's mechanical or CFX or Fluent. Okay. Now, one of the things that I always like to recommend when setting up RSM is to test any remote solve machines or any compute servers before going ahead and using them. Certainly, it's much easier to debug an issue within RSM if you find it ahead of time, and certainly it's much more difficult to find it when you submit a job and it fails and you don't know whether that job failed because of something in your setup or because of something in RSM. So one of the best practices is certainly to come into RSM, right mouse button, click on the compute server of interest that's in your queue, and test the server. Now when you test that server, it'll come up in the job window, And in the details below, you can see the details of that test. And so what we'll see is this will take a second to run through. It's submitting to the machine CAEA train 1, and that's going to come back as saying the test is completed and everything is set up fine. So when I go to submit my job from mechanical or from Workbench in general, this machine is available and properly configured to run a job. Okay, so once RSM is configured, you run through the setup wizard. How do we go ahead and use RSM within Workbench? Well, the manner in which we use RSM varies a little bit depending on whether we're using mechanical or one of our CFD products. First, let's talk about how we use it in mechanical. If I open up a dummy case here that I've set up, just a cantilever beam, and I want to go ahead and solve this problem or submit this problem to my queue. So I don't necessarily want to solve it on my local machine, but as soon as there are some compute resources available, I want to solve that remotely. Now, by default, if I just click the Solve button, that's going to run locally. If I click the little arrow next here, you'll see there are some other options. And what I want to do is set up an option within here that will submit to the remote queue, to the queue, and then ultimately be solved remotely. Now, in order to do that, I have to go to the Tools menu and set up a new Solve process. So if I select Solve Process Settings, one of the options here will be to add either a local or remote solve process setting. And this refers to, the local or remote refers to where the solve manager is hosted. So if the solve manager is on a remote machine, then I want to use the add remote option. If the solve manager is local, as in my case, I want to use the add local option. So if I add local and I'm going to give it a name, this solve process is going to be, let's say, cluster 1. And this will automatically list any of the queues that I have set up on my local machine. So if you remember, I have a queue that's called My Cluster set up in RSM. So if I come back into a mechanical, what I want to do is pick from this drop-down menu the queue My Cluster. Then if I pick the appropriate license, that remote solve process is now set up so that they can send this job off. So if I press OK here, now if I come to the Solve menu, you'll see Cluster 1 is an option. So I just click on Cluster 1. This will set up that job so that it's run remotely. If I come back to RSM, I can see it's listed in the Details pane here as this job being run through RSM, being run remotely, and it's just as easy as that. Once the job is finished, RSM will wrap all the analysis information up, download it back to the Solve Manager, and give me an indication of that in Workbench Mechanical. So you'll see I have a little green down arrow, and that means my results are finished. If I right-click, I can download them from the Solve Manager and evaluate them, and it's as easy as that. The results are evaluated. This ran remotely. A pretty straightforward process. Okay, so that's how we use RSM or submit a single job from mechanical to RSM. How about if we're doing this for one of the fluids products such as CFX or Fluent? Well, the way that we do that is a little different. Instead of setting up a solve process setting, what we want to do is from the project page, right mouse button click on the solution cell here and take a look at its properties. So if I look at the properties, by default, the solution is going to run in the foreground, and what that means it's going to run on my local machine. But I can change that to submit to the Remote Solve Manager. And from here I can specify what Solve Manager I want to use, whether it's a local or a remote machine, and then what queue I want to submit it to on that Solve Manager. Now the key here is that instead of opening up the Solve Manager and submitting the job manually, I just want to right-click and update the solution cell, and that'll take care of sending off this job to RSM for submission to the queue. Okay, so that's how we do a single design point, managing a single one-off analysis, submitting to RSM. But RSM also allows us to fully harness one of the more powerful features of the ANSYS Workbench, and that is the ability to parameterize your model. So anything within Workbench, including geometry, mesh, materials, properties, boundary conditions, and even results items, have the ability to be made parametric. And these parameters will be automatically and persistently updated by Workbench. So there's no manual going in to change the geometry or going in to type in a new boundary condition value. Let's say you have a different load value. We can make that parametric and set up design points. And there's no need for additional scripting. So Workbench takes care of all of this. And once we have a parametric model, we're going to want to evaluate more than just one design point. So for instance, if I come back to my my cantilever beam here, if I want to do a study on how the answers change, how my results change with the density of the mesh, I can set, let's say, some mesh parameter like the mesh relevance to be parametric. And if I come back to the project page and take a look at the parameter set, I can change that relevance and evaluate, okay, if I increase the mesh density, let's say I take a look at 4 different meshes, I can see how those how the results change based on that mesh that mesh parameter. So a really powerful way to explore the different inputs to your modeling, to your analysis, and how those inputs will impact your design. So if I make a subtle change, what's going to be the impact on my device? Now, more design points leads to more solutions that we have to run. And using Workbench and RSM, this is a very automatic process. So Workbench will automate the update of the inputs, and RSM can be used to efficiently manage the execution of the design points. So we can make sure that we're running them as soon as computing resources become available. And also, we can make sure that we can submit these design points and run them simultaneously. So if we take a look at an example, here I have an example of an exhaust manifold, and my goal here is to determine how the pressure drop across the exhaust manifold varies for different mass flow rates. So I have this device. I know that the mass flow rate through the device is not always going to be one single value, but rather it's going to operate under a varying conditions. And I want to see, my real goal is to develop a curve that has the mass flow rate versus the pressure drop. So I want to run a number of design points, let's say 4 design points, to get a rough idea of what that curve will look like. And so I can set up a parametric model where my boundary conditions vary. Now, from experience, running this single design point, I know it takes me roughly an hour and a half to complete. So running 4 design points, one after another, assuming one starts as soon as the next one, the last one finished, will take roughly 6 hours. Now, without RSM, that means that I'd have to be there as soon as the design, as soon as the analysis finishes, to make sure that I submit the next one, or I have to write a batch script. Instead, I can use RSM to do that for me, where I can either run those 4 design points in series, and that'll run one after another and take me the 6 hours. Now, instead, I can also use RSM to distribute those to remote machines, and I can run those in parallel. So I can run the 4 design points concurrently and get solutions for those 4 design points in the same time as the single design point. So rather than having to wait 6 hours, I can generate solutions for the 4 design points in just 1.5 hours. So a really powerful feature and a powerful way to harness RSM to explore your design space, and certainly I think hopefully you'll be able to see that there's a lot of power in knowing how your your results are influenced by subtle changes to the inputs. Now, running these design points, if we want to run them concurrently or all at the same time, requires 4 CFX licenses to be available. Now, that can, for large design spaces, can be certainly can be cost prohibitive. So if we need to run 50, 60 design points, you know, and we want to run them concurrently or as fast as possible, that can certainly be you know, stressful on the licensing side. So what ANSYS has introduced at version 14.5 is called the HPC Parametric Pack. And what the HPC Parametric Pack does is essentially amplifies the number of design points that can be solved with one set of licenses. So if we think about the exhaust manifold problem or the cantilever beam problem, if I wanted to run 4 design points concurrently without an HPC Parametric Pack, I need 4 either CFX or mechanical licenses. Now instead, what I can do is use the HPC Parametric Pack to amplify a single a mechanical or CFX license. So to run those 4 design points, I'd need 1 CFX license and 1 HPC Parametric Pack license, and then I could run those 4 design points concurrently. Now the HPC Parametric Pack licenses scale similar to how the HPC licenses scale. In that 1 pack will give you 4 design points, 2 packs will give you access to 8 design points, 3 to 16, et cetera, et cetera. So essentially, it's acting as, again, a multiplier on the base licenses. So if we take a look at the same example, with an HPC Parametric Pack, I needed only 1 CFX license to run the 4 design points. Again, in the same amount of time, because I'm able to run them concurrently using RSM, and in a much more cost-effective manner. So I don't need to tie up 4 CFX licenses. I can use the 1 CFX license and the HPC Parametric Pack. Okay, so that's all we have for you today. In summary, ANSYS RSM allows for efficient management of computing resources. And with RSM, it allows us to fully harness the parametric capabilities of ANSYS Workbench. So we can run a lot of jobs, we can freely explore our design space, and we can use RSM to manage our computing resources